In this video, I want to talk a bit about unfalsifiable theories, so theories that have no way to be proven false. But I'm going to start out by talking about predictions that a theory makes. So in general, theories are useful because they make predictions about things that we can't actually observe, and that may be because there's like so many possible points to observe that we could never observe them all. So for example, we have a theory of gravity, and that's useful because there's so many points out there that we could never observe every single point in the universe. So it helps to have an idea of how things might behave at all of those points, even though we can't observe them. So we have a whole bunch of points that we've never observed, but we can make predictions about how they behave because we have a theory that covers those points. And every single point that we haven't actually observed is a point that we could test to see if it is still consistent with the theory. And if any single point happens to be false, then the theory is just now proven false with the single counterexample. So if we have a whole bunch of points that we can observe to test the theory, so the theory has a lot of points that we could test, then that means the theory also, in some ways, has a lot of ways to be wrong or to be falsifiable. It could be made wrong in a lot of different points. Now, if we had a theory that was unfalsifiable, so it couldn't be wrong, that sounds good if we have something that's never wrong, if we come up with an idea that's never wrong. But what that actually means is that we have a theory that has no observable points. It makes no observable predictions. So there's no real practical use to the theory because it doesn't tell us anything that we don't already know. So it could introduce a way of thinking, so it could give us some ideas about how to think about something, but there's no way to ever actually justify it or show that it's actually true because there's no points to observe to show that it's true or false. It's just an unfalsifiable theory, and we can never prove it either way. So, as an example, I said maybe our sensations are simulated and not real. That's a theory, and it's unfalsifiable because no matter what we experience, we could argue that it's a simulated experience and it's still not real. And that's true no matter what we observe, no matter what we experience. So the theory can never be proven false, but it also can't be proven true, and it doesn't make any predictions about how something would behave that we could use. So it's never wrong, but it's not really useful. So if we added something that could be observed, then the theory would become falsifiable because maybe we make the observation and it doesn't match, but that would also make the theory useful because it would tell us something that we didn't know. So, for example, I could add on to that theory and say, well, if we perform these certain actions, then we can actually escape the simulation. And now this theory is making a prediction, and there's something that we could observe to test it. So we could say, we could then do those actions, and if we don't escape whatever simulation we're in, all of a sudden we know the theory is actually false. So this theory is no longer unfalsifiable. It could be made false by checking the observation point. But arguably, that actually makes it useful because now it tells us something that we can do, something that we can observe that we didn't know before. Whereas on the other hand, if we just say our sensations are simulated and not real, well, we can't use that theory to predict how anything behaves. If we could, like if you attach some kind of prediction about how something behaves to the theory, then that's a point where you could observe and see if it's consistent. And then that would make the theory falsifiable and useful. So this isn't just some kind of crazy thing. There's also science-related examples that you could have. So there's an idea of true randomness, where maybe things aren't, we don't just model something as random, it's actually truly random, and there is no actual reason behind it. But this is one of those unfalsifiable theories, so unless you attach some kind of prediction to it about how something can or can't behave, you can never prove the theory false, but you can never make any predictions from it, or you can never use it in anything practical because it doesn't make any predictions of its own. And that, so like, no matter what outcome you observe, you could argue that it's the result of something truly random. So you could argue that the theory is never wrong, but it's not useful because there's no falsifiable points. It doesn't make any predictions. And the same thing is true if you talk about something like observing something has an effect on its behavior. So it could be true, it could be false, but it's unfalsifiable because we can never make the observation without observing it. So no matter what result we get, in some way we've observed something to get the result, and then we could argue that, well, we changed the outcome because we observed it. But unless it makes some prediction about how the outcome changes or what the effect is, it's not a useful theory. So it's never wrong, it's not falsifiable, but it's also not useful. You can't use it to predict anything. You can't use it to like understand anything better or come up with how something works because it doesn't make any predictions. And again, if it does make a prediction, it becomes falsifiable because you could test those predictions and see if they hold. So, to talk about falsifiable theories, they can be wrong. So, but because they can be wrong, that means they're also making predictions about things. And any point that we haven't observed yet could become a counterexample, and it could make our theory instantly wrong. But it's not bad for the theory to have points where it could be wrong. That's what makes it useful. So I think when I say that a theory could be, like, false theories can be useful, I think that some people could take that to mean that, well, it's like, if you fail, then you're still making progress and you have to fail a lot of times before you succeed. But it's not something like that. Like, that's a small part of it. Like, sometimes that is true and sometimes that's how things go, but it's a lot more than that. So if you have a theory that has the potential to fail, that means it's also making a lot of predictions, and that means you can use it to predict things that you otherwise couldn't observe, sometimes because there's just so many things that you can't observe all of them. So by having a theory that has points where it could fail, you actually have a useful theory. And the bigger your theory is, like the theory of gravity covers like all matter pretty much, that means there's so many more points where it could fail. But it makes it also that much more useful because it covers every point out there. So you don't really want to find theories that are correct. That's not the goal of coming up with a theory. You want to find theories that have the potential to be wrong but still seem to be correct, because in that way they're making a lot of predictions and they're useful.